All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
How do we decide the addition of various compounds about the double bond? Let's see in this class. अगर आप इस कॉन्सेप्ट को और डिटेल में समझना चाहते हैं तो एस चांद पब्लिशिंग की एक बुक है जिसे आप पढ़कर और अच्छे से समझ सकते हैं, जिसका कवर मेरे स्क्रीन पे दिख रहा है एंड इसका लिंक नीचे शेयर किया गया है, तो आप उसे भी कंसिडर कर सकते हैं. हाय, आई एम मनीषा सिंगला. वेलकम टू द एस चांद अकेडमी. इन दिस क्लास वी विल बी टॉकिंग अबाउट alkenes, their basic nomenclature, physical and chemical reactions and the properties. Alkenes are also hydrocarbons that we all know. They are unsaturated hydrocarbons, that means they contain a double bond between the carbon atoms. The general formula is CnH2n, where n is the number of carbon atoms. Because they have fewer hydrogen atoms as compared to the alkenes which we studied in the last class, with the same number of carbon atoms, the hydrogens being lesser, they are called unsaturated. The simplest alkene is ethene, which has a double bond between two carbon atoms and two hydrogen atoms on each carbon. Alkynes are also unsaturated hydrocarbons, which maybe we will be studying in the subsequent classes. So, here in the alkenes, the carbon-carbon double bond acts as a functional group. Till now, we talked about alkanes which have a single bond, and that single bond was supposed to be very stable. But here in alkenes, we have a double bond between the carbon atom. Hence, the double bond will determine the chemical reactions that will be taking place in an alkene. Let us talk about the physical properties of alkenes. Firstly, coming to the melting and the boiling points. The alkenes have lower melting and boiling points because lesser amount of energy is required to overcome the weak intermolecular forces of attraction between the simple alkene molecules. Since we have a double bond here, the molecule becomes weaker as compared to the alkane. The breakdown of the molecule becomes easier as compared to the alkane, and so both the melting point and the boiling point will be lesser as compared to the alkanes. As the number of carbon atoms per molecule increases, the melting point and boiling point would increase. In a similar manner as we studied in alkanes, here also as जैसे जैसे आप कार्बन का नंबर बढ़ाएंगे, नंबर ऑफ कार्बन एटम्स इंक्रीज होंगे, मॉलिक्यूल का मॉलिक्यूलर वेट बढ़ेगा, वैसे वैसे उसका सरफेस एरिया बढ़ेगा एंड इसलिए उसका मेल्टिंग पॉइंट और बॉइलिंग पॉइंट दोनों ही इंक्रीज हो जाएंगे बिकॉज इट विल रिक्वायर मोर अमाउंट ऑफ एनर्जी टू ब्रेक डाउन. The size of the molecule becomes bigger and the intermolecular forces grow stronger. More energy is required to overcome these stronger forces of attraction, and hence the melting and the boiling points would increase. At room temperature, the first three alkenes, that is ethene, propene and butene, are gases in nature, and the alkenes containing more than 5 carbon atoms are liquids or solids. Just like the alkenes also have very low density. They are insoluble in water, again because they are non-polar in nature, so they cannot dissolve in a polar solvent. They dissolve in non-polar solvents, do not dissolve in water, and hence they will float on water. Similarly, just like the alkanes, they can be used to prevent corrosion. However, the densities of the alkenes increase with the increase in number of carbon atoms per molecule. जैसे जैसे कार्बन आटम्स का नंबर बढ़ता जाएगा एल्कीन्स में, उसकी डेंसिटी भी बढ़ती जाएगी. जस्ट लाइक द alkenes are insoluble in water, as I have told you. Since they are insoluble, they will float on water and they will not conduct electricity. The major requirement for conducting electricity is to have free ions, but since they contain double bonds, ionic formations will not take place in alkenes, and because there are no mobile ions in the solution, hence they will not conduct any electricity. Alkenes are comparatively more reactive than alkanes. This is basically because of the double bond that is present here. The CC single bonds are stronger, but the CC double bonds are comparatively a little weaker and more reactive. All of the reactions of the alkenes would occur about the double bond only. That means the double bond will help in substitution, will help in addition or everything. So, major changes that will be taking place in the alkene on any reaction, that will be taking place on the double bond or on the carbon atoms which contain the double bond. Here also the major reaction of the alkenes is combustion. As I have already told, combustion is burning in excess of oxygen, and whenever a hydrocarbon will burn in excess of oxygen, it will produce carbon dioxide and water with the release of certain amount of energy. Similarly, just like the alkanes, अगर complete combustion नहीं होता है, oxygen insufficient है, तो it will break down into carbon dioxide and water along with the generation of carbon monoxide, which is toxic, and in both the reactions there will be a release of energy. The most important reactions of the alkenes are the addition reactions. An addition reaction, as we know, is a reaction in which atoms or groups of atoms are added to each carbon atom of a carbon-carbon double bond to form a single product. जितना भी एडिशन होगा, कोई भी केमिकल आप रिएक्ट करें अल्कीन के साथ, कोई भी एडिशन रिएक्शन जो होगा वो उन दो कार्बन एटम्स पे होगा जिनके बीच में डबल बॉन्ड है. Let us take first the addition of hydrogen. Ethene reacts with hydrogen at 180 degrees Celsius in the presence of nickel or platinum as catalyst to produce ethane. This process is called catalytic hydrogenation. Hydrogenation मतलब addition of hydrogen, catalytic मतलब in the presence of a catalyst. As I told, alkenes are reactive or more reactive than alkanes, but yet they are not as reactive as the other chemical compounds. So, for hydrogenation they will be needing a catalyst and also a high temperature which will allow the reaction to proceed in the forward direction. That means at 180 degrees Celsius, when you react an alkene, say ethene with H2, that is hydrogen gas, you will get ethane. That means one hydrogen from the hydrogen molecule will get added on each side of the double bond, and instead of CH2 double bond CH2, you will have CH3 single bond CH3, that is ethane. Hydrogenation reaction is basically used to convert the unsaturated compounds into saturated compounds, as we have seen here, that is for the conversion of the alkene to the alkane. Double bond की जगह single bond बन जाता है by the addition of one hydrogen on each side of the double bond. Then next is halogenation reaction, that is addition of the halogen. Halogens, as we know, are chloride, bromide and iodide. They react very readily with alkenes. We do not need any catalyst, we do not need to raise the temperature of the reaction, they will straight away react easily. No ultraviolet light is required here. When ethene, for example, is bubbled with a solution of bromine in water, in the dark the red brown coloration of the bromine is decolorized and we get a colorless liquid, that is 1,2-dibromoethane is formed. That means if I take up ethene, that is CH2 double bond CH2, react it with bromine, that is Br2, then one Br atom gets added to both the hydrogens on the which are next to the double bond. दोनों कार्बन्स के ऊपर एक एक ब्रोमीन आटम लग जाएगा. इस प्रोसेस का जो फिजिकल अपीयरेंस होता है वो ये होता है कि जब आप ब्रोमीन वाटर लेते हो दैट इज स्लाइटली ब्राउन इन कलर, लेकिन जब आप उसको एल्कीन में मिक्स करते हो तो वो कलर फेड हो जाता है एंड इट बिकम्स अ कलरलेस सोल्यूशन बिकॉज ऑफ द फॉर्मेशन ऑफ 1,2-dibromoethane, right. So, this reaction is also used as a test to analyze or to check the presence of the carbon-carbon double bond. इसका मतलब अगर डबल बॉन्ड प्रेजेंट है तो वो ब्रोमीन के साथ रिएक्ट करेगा और 1,2-dibromo डेरिवेटिव बना देगा जिससे कि उसका कलर चला जाएगा. If suppose there is no double bond, then the color of bromine water will not change. कलर ब्राउन ही रहेगा. अगर डबल बॉन्ड प्रेजेंट नहीं है तो कलर will not change, right. So, it acts as a test for the double bond. Now, next is hydration. Do you know what is hydration? What is the chemical compound that will be added to alkene for hydration? We'll see after a short break.
So myself Nitin Puri, who will be coming with more number of lectures for you to have more number of topics in the engineering field so that you can have a better understanding of the subject on S-Chan platform. I hope you will enjoy it. Thank you.
Welcome back to the S. Chand Academy. Before going on a break, I asked you what is hydration. Hydration, as the name suggests, is the addition of water. That means आप alkene के about एक water molecule add करेंगे. We know water is H2O and we can also write it as HOH. That means जो double bond के about addition होगा, एक तरफ H add होगा और एक तरफ OH add होगा. So if I have CH2 double bond CH2 and it reacts with water, it will form CHOH one more, and on the other side you will have a single bond and CH2OH हो जाएगा. However, the alkenes do not generally react with cold water under the ordinary room temperature. We have to provide certain conditions. That is, we will be using phosphoric acid as a catalyst to enhance this reaction, and a temperature of 300 degrees Celsius and 6 atmospheres will be required to make the desired product. So, the product that is formed is known as ethanol, that is CH2OH. Similarly, we have addition of the hydroxyl group. Hydroxyl group is the OH group. Ethene reacts with water in the presence of dilute acidified potassium KMnO4. That means it is a similar reaction, we are adding water, but here we are changing the conditions of the reaction, and on changing the conditions of the reaction, the product will also change. So, if we react ethene with water in the presence of dilute acidified potassium manganate solution, then the product that is formed is ethane 1,2-diol. Ethene here also decolorizes the purple solution, that is the acidified potassium permanganate solution, which is purple in color, on reaction with ethene will become colorless. So, potassium permanganate can also be used as a reagent to check the presence of the double bond. So, here in the reactions we have seen, in the earlier reaction with water, what we were doing, we were adding hydrogen and OH about the double bond, but here OH and OH will be added about the double bond instead of one H and OH. So, both bromine water and acidified potassium permanganate will act as a test for the double bond. So, in a similar way, we can add hydrogen halides. Hydrogen halides, that means HCl, HBr, HI, etc. They will also be added to the alkene in a similar way. तो अगर हम ethene लेते हैं CH2 double bond CH2, HCl के साथ रिएक्ट करते हैं तो एक कार्बन पे H ऐड हो जाएगा और एक कार्बन पे क्लोराइड ऐड हो जाएगा. तो we will have CH3 CH2 Cl. Now, this is when we have symmetric alkenes. If suppose we have unsymmetrical alkenes, मतलब दो कार्बन आटम वाले एल्कीन की जगह मेरे पास 3 कार्बन वाला एल्कीन है, प्रोपीन है. तो प्रोपीन में क्या है, CH3 CH2 double bond CH2. Now there is one carbon which has 2 hydrogens next to the double bond, and there is one carbon which has a CH3 group along with the hydrogens on the double bond. Here, addition of the hydrogen halide to propene can lead to the formation of 2 possible products. अब अगर मैं HCl ऐड करती हूँ प्रोपीन के अराउंड तो क्या होगा? One situation is कि hydrogen gets added to the carbon which is having the alkyl group also, and the chloride gets added to the CH2 group. The other possibility is कि जो chloride है वो मेरा CH3 containing carbon पे attach हो जाए और हाइड्रोजन जो है वो CH2 पे अटैच हो जाए. तो 2 पॉसिबिलिटीज़ हो गई, 2 प्रोडक्ट्स फॉर्म हुए. हाउ विल वी डिसाइड विच प्रोडक्ट शुड बी फॉर्म्ड और हाउ डू वी गेट टू द डिजायर्ड प्रोडक्ट? नाउ फॉर गेटिंग द डिजायर्ड प्रोडक्ट वी हैव अ रूल which was given by the scientist Markovnikov. According to Markovnikov, whenever the addition of a protic acid means hydrogen halide की हम बात कर रहे हैं, that is HX, takes place or the addition of water takes place to an alkene, the hydrogen attaches to the doubly bonded carbon with the greater number of hydrogen atoms, while the halogen gets added to the carbon with lesser number of hydrogens. That means it is often interpreted as the rich gets richer. That means जिस कार्बन के पास पहले से ही ज़्यादा हाइड्रोजन्स हैं उसी पे हाइड्रोजन ऐड हो जाएगा, और जिस कार्बन के पास लेसर हाइड्रोजन्स हैं, नाउ व्हेन वी आर काउंटिंग द हाइड्रोजन्स we will not be counting the hydrogens of the alkyl group, only the hydrogen that is directly attached to the carbon in consideration. तो डबल बॉन्ड के अराउंड जो दो कार्बन्स हैं उनमें जिसके पास ज़्यादा हाइड्रोजन है वहाँ पर हाइड्रोजन ऐड हो जाएगा, और दूसरे कार्बन पे हेलोजन या OH जो भी हमारे पास है वो ऐड हो जाएगा. दैट इज़ द मार्कोनिकॉव रूल. सो इन दिस केस इफ़ वी अगेन टॉक अबाउट प्रोपीन, तो प्रोपीन में अगर हम HX ऐड करते हैं तो सिंस CH2 हैज़ लार्जर नंबर ऑफ हाइड्रोजन्स, द H गेट्स एडेड टू CH2, और जिस कार्बन पे CH3 था वहाँ पर एक ही हाइड्रोजन है तो वहाँ पे Cl ऐड हो जाएगा. सो दिस इज़ द मार्कोनिकॉव्स रूल. However, if I want the other product, then there is another rule which is called the anti-Markovnikov rule, also the Kharash or the peroxide effect. That means I can alter the desired product by the addition of a peroxide in the same reaction. प्रोपीन को अगर मैं HX के साथ या वाटर के साथ रिएक्ट कर रही हूँ and I use a peroxide as a catalyst in this reaction, then instead of getting the Markovnikov result, I will get the anti-Markovnikov result. That means the hydrogen will now get added to the carbon which has lesser number of hydrogens, and chloride gets added to the carbon which has higher number of hydrogens. Now, anti-Markovnikov rule is exactly the opposite of Markovnikov's rule. That means it will give me the opposite result. When HBr is added to the alkene in the presence of the peroxide, hydrogen atom bonds to the doubly bonded carbon that has lesser number of hydrogen atoms, which I have already told you. Markovnikov reaction is an ionic reaction, whereas the anti-Markovnikov addition is a फ्री रेडिकल मैकेनिज्म. मतलब दोनों रिएक्शंस का जो मैकेनिज्म है वो डिफरेंट है. मार्कोनिकॉव एडिशन में आयन फॉर्मेशन होगा और एंटी मार्कोनिकॉव में फ्री रेडिकल फॉर्मेशन होगा. द मैकेनिज्म टेक्स प्लेस एज अ चेन रिएक्शन एंड हैज़ 3 स्टेप्स. हम स्टेप्स ऑलरेडी एक रिएक्शन के डिस्कस कर चुके हैं, इनिशिएशन, प्रोपगेशन एंड फाइनली दी टर्मिनेशन स्टेप्स. तो दोनों ही इफेक्ट्स का, दोनों ही रूल्स का मैकेनिज्म डिफरेंट रहेगा. During the final step, the more stable bromoalkyl free radical reacts with HBr in case of the anti-Markovnikov rule and produces another bromine free radical which continues the chain reaction. तो free radical bromines form होते रहेंगे in case of the Kharash effect because of the presence of the peroxide, and we will get a product that is different from the Markovnikov addition. Now, the last reaction is polymerization. We have all heard about polythene. What is polythene? Polythene is basically a polymer of ethene. जब बहुत सारे ethene molecules combine करते हैं together, they form a big molecule which is a polymer of ethene, and that is known as polythene. That means whenever small alkene molecules readily undergo an addition reaction with one another, मतलब हम यहाँ ऊपर से कुछ एडिशन नहीं कर रहे हैं, एल्कीन मॉलिक्यूल्स अपने खुद के मॉलिक्यूल्स के साथ रिएक्ट करते हैं टू फॉर्म अ पॉलीमर, एंड इन दिस प्रोसेस हंड्रेड्स एंड थाउजेंड्स ऑफ मॉलिक्यूल्स कैन कंबाइन टुगेदर एंड गिव यू अ लार्ज चेन which has a very high molecular weight, and that is known as a polymer. So, the alkenes readily undergo polymerization reaction, and the basic unit of a polymerization reaction is called a monomer. मतलब जो भी सबसे छोटा रिपीटिंग यूनिट होता है उसको हम मोनोमर बोलते हैं. एंड द पॉलीमराइजेशन रिएक्शन इज ऑब्वियसली एन एडिशन रिएक्शन जहाँ पर मॉलिक्यूल्स आपस में मिलते रहते हैं, कंबाइन करते रहते हैं. द पॉलीमराइजेशन ऑफ ईथीन इज कैरिड आउट बाय हीटिंग ईथीन at about 200 degrees Celsius and a pressure of 1200 atmospheres in the presence of traces of oxygen. So, that means it is evident from what I have just said कि reaction अपने आप नहीं होता है. You have to provide certain conditions, you have to give a very high pressure, you have to have a certain amount of oxygen and also a temperature of about 200 degrees Celsius, so that the alkene molecules or the ethene molecules can join together and form polythene. The product polythene, also known by its trade name, which is also polyethene, is most commonly used, it is the most commonly used synthetic polymer. It is used for making films, sheets for bags, wrappers, and for making mold articles such as toys, bottles and squeeze bottles. Obviously, the polythene that is used, the characteristics of the polythene are changed depending upon the variety or the type of the product that needs to be made. This slide shows the formation of the polythene molecule. As you can see here, different repeating ethene molecules are combining together to give you the final polyethene molecule. So, in this class we talked about alkenes, their physical and chemical properties and also their reactions.
अगर आप इस कॉन्सेप्ट को और डिटेल में समझना चाहते हैं तो एस चांद पब्लिशिंग की एक बुक है जिसे आप पढ़कर और अच्छे से समझ सकते हैं, जिसका कवर मेरे स्क्रीन पे दिख रहा है एंड इसका लिंक नीचे शेयर किया गया है, तो आप उसे भी कंसिडर कर सकते हैं।
अगर आपको वीडियो अच्छा लगा तो लाइक, सब्सक्राइब और शेयर ज़रूर कीजिए। बेल आइकन दबाना मत भूलिए ताकि आपको हमारे आने वाले वीडियोज़ का पता चलता रहे।